Dear students, in today's class, we will see problems on CDF and CDF, continuous random variable, and cumulative distribution function. The problems are cumulative distribution function. Okay. So now the problem says the cumulative distribution function for the random variable x. Cumulative distribution function for the random variable x is f of x with the random variable x, which is a function 1 minus exponential of minus x square by 4, comma, within the condition x greater than or equal to 0 or 0 otherwise. Evaluate probability of p of 1 comma 1 less than x less than or equal to 2.1. Okay. Solution is, we already know that the probability of x1 less than or equal to x2, which is equal to fx2 minus fx1, which is already proved. We have proved. We know that probability of x1 less than or equal to x2, which is f of x2 minus f of x1, which is already proved in previous class. See here. Already proved in the previous class. So we know that already. Okay, substitute f of x2. F of x2. What is f of x2? Here f of x2. x2 is, in place of x we have x2. In this problem x2 is 2.1. Substitute in place of x2 2.1. Then we get 1 minus e power, because 1 minus exponential of minus x square by 4. Here we are substituting 2.1 whole square. In place of x, we are substituting 2.1, because we already know that probability of x1 less than x less than or equal to x2, which is nothing but capital F of x2 minus capital F of x1. That's why we are substituting in place of x as x2, x2 in place of x as x2. x2 in this problem is 2.1. 1 minus e power minus 2.1 whole square, 2.1 whole square divided by 4 minus f of x1. F of x1 means f of x1, because x1 is greater than or equal to 0. Greater than or equal to 0. Therefore, x1 in this problem, x1 is 1.1. Therefore, so we are substituting in place of x 1.1. 1.1 in place of x, then we get 1 minus e power minus 1.1 whole square by 4, because f of fx of x with respect to a random variable x is given by, this is the function. This is function. Okay, given function. Therefore, we get 1 get cancelled, 1 minus 1 get cancelled, minus e power 2.1 whole square by 4, minus into minus plus e power minus 1.1 whole square by 4 gives e power minus 0.3024 minus e power minus 1.1025. By using calculator, we get 0.407 final answer. Okay, this is the problem on cumulative distribution function. Okay, we'll see next problem. Problem number 2. The cumulative distribution function for the random variable y is, here random variable is y. Okay, Fi of y. Small y is random variable value of the random variable y. This is values, certain values of random variable y. Okay, this is the function says 1 minus exponential of minus 0.4 y power 0.5, which is same thing as the previous problem, y greater than or equal to 0 or 0 otherwise. Evaluate probability of 2.5 less than y less than or equal to 6.2. We already know that probability of x1 less than x2, which is equal to f of x2 minus f of x1, which is already in previous class we already proved this equation. Substitute in place of here in this problem f of x2. Here x2 is x1, x2 is 6.2. 6.2. Substitute in place of x as 6.2 we get in this, because y, what is y here? 6.2. y2 is 6.2. y2 or x2, because which is greater than or equal to 0, therefore we use this function 1 minus exponential of 0 minus 0.4 into y power 0.5x. Okay, substitute 6.2 in place of y. In place of y, we get first in this term, substitute in place of y as 6.2, then minus substitute in place of y in this term as 2.5, because this is x2, this is x1. Okay, substitute x1. X1 means y. What is y? x1 is 2.5. Substitute in place of y as 2.5, we get same thing in the last problem as last problem. 1 get cancelled, and minus e power 0. minus e power minus 0.4 into 6.2 whole power 0.5 minus into minus plus e power minus 0.4 into 2.5 power 0.5. Okay, then by using calculator we get 0.1619. Okay, this is the second problem of cumulative distribution function. We'll see the third problem is same as first and second problem. Okay, then this is question appeared in model question paper. The following is the probability density function. PDF means probability density function for the random variable u. Here random variable is u. Small u is certain values of random variable u. Okay, fu of u, which is a function c is a constant c into exponential of minus u by 2 that is the given condition 0 less than u less than 1. The u is in between 0 and 1, which is equals to 0 but less than 1. Okay, or 0 otherwise. Find the value that c must have and evaluate fu of 0.5. fu of 0.5. Capital fu. What is capital fu? Is cumulative distribution function of the random variable u of certain value 0.5. Okay, we know that for probability density function, area under the curve is unity. In the previous class we already proved that area under the curve is unity. They are proved as area under the curve is unity for the probability density function. Okay, that is minus infinity to infinity, integral from minus infinity to infinity, fx of x. Here fx is probability density function. This is the function probability density function of random variable x, certain value x with respect to x, which is equal to 1. This is PDF. It's nothing but PDF, probability density function. Probability density function of a area under the curve is unity, which is unity means which is equals to 1. We already proved in the previous class. Okay, here limits are, what are the limits? 0 to 1. Okay, we substitute 0 to 1, integrate from 0 to 1, c into what is fx of x. Fx of x with here random variable is u. We already considered as x is a random variable, but if assume u is a random variable, then we replace x by u. Then fx of x with respect to x is c into exponential of minus u by 2. Here we are replacing x by u minus u by 2. with respect to u, because we are here random variable is u, therefore with respect to u, which is equal to 1. Okay, c into integrate this one. C is constant outside the integral, and this integrate this e power u minus u by 2. Yes, e power minus u by 2. We are integrating e power minus u by 2 under the limits 0 and 1. We get e power minus u by 2 as it is divided by that coefficient minus 1 by 2. Minus 1 by 2. We get in under the limits 0 and 1, which is equals to 1. Then denominator of denominator minus 1 by 2 goes numerator. Therefore, 2 minus 2 into c e power minus 1 by 2. 1 by 2 means upper limit minus lower limit. Here, upper limit, first we apply upper limit. So, apply means substitute in place of u as 1, and then minus lower limit, substitute 0 in place of u. Then we get e power minus 1 by 2 minus e power minus 0 by 2, which is equals to 1. The RHS is 1. Then we get 2c into by use of calculator, e power minus 1 by 2 is 0.606, and minus e power 0 by 2 is 0 by anything is 0. Therefore, e power 0 is 1. E power 0 value is 1. Therefore, 0.606 minus 1, which is equals to 1. Minus 2c, 1.606 minus 1 gives minus 0.3934, which is equals to 1. We multiply by 2. We multiply this by 2, c into minus 2 into 0.3934. We get 0.786 into c, which is equals to 1. C is in LHS, and this numerical part comes the RHS, which is 1 by 0.786 gives 1.26. Understood? This simple problem. This is appeared in model question paper. This is important problem. Okay. And evaluate continuation of this problem, and evaluate FU of 0.5. FU of 0.5. We know that what is cumulative distribution function? The definition says fx of x, which is integral from minus infinity to x, fx of x into dx. Fu of u, we are substituting. Here we are considering random variable as x, and here specifically we are considering as the problem here random variable is u. Therefore, fu of u, which is equal to integral from 0 to u, because integral from 0 to u, the limit says 0 to 1, because the limit says 0 to 1, but here the definition says minus infinity to x, but limits from 0, starting from 0, and the random value of some random variable is here taken as small x, and here we taken as small u. Okay, c into e power minus u by 2 into du. What is c value? C value is 1.26. We already find 1.26. C value as 1.26. Okay, 1.26 into e power minus u by 2 with respect to u. Okay, the 1.26 constant take outside the integral and integrate e power minus u by 2. Integration of minus u by 2, e power minus u by 2 gives e power minus u by 2 minus 1 by 2 within the integral, within the limits u 0 to u and 0. Upper limit is u and the lower limit is 0. Okay, denominator of denominator goes to numerator, or write same thing as it is 1.26 by minus 1.26, because which is the denominator is independent of this u. Therefore, we are taking outside, then 1.26 by minus 1 by 2 e power minus u by 2 minus e power 0 by 2. We are applying upper limit first and then lower limit. Upper limit minus lower limit. Then we get fu of u, which is 1.26 minus by 1 minus 1 by 2 into e power minus u by 2 minus 1, because e power 0 is 1. Therefore, fu of 0, substitute in place of u 0.5. 0.5 in place of u, we get 1.26 minus 1 by 2 e power 0.5 by 2 minus 1, which gives minus 1.26 into minus 2 gives minus 2.52, and e power minus 0.5 by 2 minus 1 and minus 2, which implies minus 2.52 into minus 0.22. Therefore, finally multiply minus 2.52 minus into minus gives plus, and multiply these two parts, then we get fu of 0.5 as 0.5574. 0.5574. This is the problem, which is important problem, which is already appeared in that model question paper. Okay, this is important problem. Okay, this is same thing as previous problem. The problem says the following is the probability density function for the random variable u, and the given function fu of u is c into exponential of minus u by 3. In place of 2, here we have minus u by 3. In place of 3, we have in previous problem we have 2 here, and in this problem we have 3 here. Therefore, the same thing, fu of here 0.5, fu of 0.5. Okay, this is similar problem. Answer C. Answer is the constant. First we have to find constant value, then we have, by using constant value, we have to find fu of 0.5, that is C is 1.1759 and fu of 0.5 is 0.5416. Yourself do it as same, which is same as previous problem. That's why do it. Okay, you should do by your own. Okay, this is also one problem. The answer is this, the constant value is this, and the fu of 0.5 is this one. Okay, you should do it by your own. Next, the probability density function is described by c into x minus 6 for all values of x between 6 and 10, 6 and 10 and 0 otherwise. For all between 6 and 10, 0 otherwise, which means the problem, find the value that c must have. Find the value that c, what is the value of c? We have to find the value of c and evaluate probability of x greater than 8.0. Okay, this is the problem. The problem says, given fx, the probability density function, effects of small effects of x with the random variable x between 0 to 6 to 10. The function is c into x minus 6 between 6 and 10. C into x minus 6, 6 less than x less than 10, and 0 otherwise. 0 otherwise. Therefore, the problem appears like this. Okay, we know that first we have to find the value of c. We already know that the area of probability density function, the area of under the curve, the area under the curve is unity. The area under the curve is unity. Therefore, by the use of that statement or that theorem, we already know that integral from minus infinity to infinity, fx of x with respect to x, which is equals to 1. Here the limits from 6 to 10, 6 to 10, integral from 6 to 10 c into x minus 6. Fx of x is x minus 6 because limits are from 6 to 10. Okay. Therefore, integral from 6 to 10 fx of x dx. Here fx of fx is x into c into x minus 6. C into x minus 6 with respect to x, which is equals to 1. Therefore, the constant same as previous problem. Constant, take it outside the integral and integrate x minus 6. Integration of x gives x square by 2 and minus integration of 6 gives 6x under the limit 6 and 10, which is equals to 1. Okay, c into x square. First we have apply upper limit x square 10 square minus 6 into 10. No. X square we are applying individually. We are applying this for this function upper limit and lower limit. Okay. First we apply 10 minus 6 square. 10 square minus 6 square divided by 2. LCM is 2. Therefore, 10 square minus 6 square minus 6 into x here upper limit minus lower limit. 6 into 10 minus 6, which is equals to 1. C into 10 square 100. 10 into 10 100 minus 6 into 6. 6 into 6 36. 64 gives 100 minus 36 gives 64. 64 by 2 gives 32. 32 minus 6 into 10 minus 6 gives 4. 6 into minus 6 into 4, 24 minus 24 gives 32 minus 24, which is equals to 1. C into 32 minus 24 gives 8. C into 8, which is equals to 1. Therefore, the value of C is 1 by 8. The value of C is 1 by 8. Then the continuation of this problem is find the value of that C. We already found that. Well, what is the value of C and evaluate probability of x greater than 8.0. Probability of x greater than 8.0. We have to find fx of x, cumulative distribution function of x. 8.0 means 8. Upper limit is 8. Therefore, fx of 8, which is 0 to x. The definition says fx of x, which is equals to 0 integral from 0 to x fx of small fx of x with respect to x. Therefore, here upper limit is 8. Therefore, lower limit is 6. Lower limit is 6 here given in the problem. Okay, lower limit is 6 and upper limit is 10. Otherwise 0. Except this limits, otherwise 0. The function is 0. Okay, therefore the upper limit is 8, lower limit is 6. Therefore, the function is c into x minus 6 with respect to x. 6 to 8, c into x minus 6. Okay, integral from 6 to 8. What is c value? Already found that c value is 1 by 8. 1 by 8. The c value is 1 by 8. Substitute in place of c as 1 by 8. 1 by 8 into x minus 6 into dx. 1 by 8 is a constant. Take it outside the integral. Then integrate x minus 6 with respect to x. X square by 2 in the same as in the previous. Same as in the. We are using. We already used during. We already used during this part, during finding this part. Okay, the x square by 2 minus 6x by integrating x minus 6 we get x square by 2 minus 6x under the limit 6 to 8. Substituting upper limit first minus lower limit. 8 square minus 6 square by 2 minus 6 into 8 minus 6 gives 8 square 64 minus 36. 64 minus 36 gives 14 minus 8 minus 6. 64 minus 36 gives 28 by 2. 28 by 2 gives 14 minus 6 into 8 minus 6. 6 into 8 minus 6 is 2. 6 into 2 is 12. 14 minus 12 is 2. 1 by 8 into 2 gives 1 by 4. Therefore, the probability of fx of 8 gives 1 by 4. Therefore, probability of x greater than 8 gives, this is identity. This is identity. Probability of x greater than 8, which is equals to 1 minus probability of x less than or equal to 8. The probability of x greater than 8, which is a complement of, this is complement of this. The complement of probability of x greater than 8 is 1 minus probability of x less than or equal to 8. Therefore, 1 minus fx of 8. Okay, 1 minus probability of x less than or equal to x, which is nothing but cumulative distribution function. Therefore, 1 minus fx of x. Fx of x, here x is 8. Fx of 8, we already found that fx of 8 gives 1 by 4. Therefore, 1 minus 1 by 4 gives 0.75. Therefore, 0.75. Probability of x greater than 8.0 gives 0.75. Okay, understood? This is the easiest problem, and which is also appeared in model question paper, I think. So this is also important, and this problem is same as previous problem. We should do it by your own. Same limits 6 to 10. Okay, this is a problem in this sentence. You should make this problem as symbolically as this, symbolically same as this. Okay, fx fi of y, in place of here y is a random variable. In previous problem x is random variable. Okay, no change in probability of y greater than 7.0. You should do it by your own. Okay, first we have to find c, and then we have to find the probability of that y greater than or equal to 7. Then by using complement function, you have to find probability of y greater than 7.0. Okay. This is problem also same as previous problem. The limits are same, but here random variable is z. Same thing. That limit is 9. Okay, z the random probability of z greater than or equal to 9.2. This is same. First here same as first we have to find the c value, constant value, and then we have to find the fz of 9, and by using probability function, complement of probability function, we get probability of z greater than 9, which is equal to 11 by 32. Okay, understood? Okay, next in next class we will continue in the next class.